we were discussing last time the influence lines, and this is not the new word for you. And however, the description that will also be given in this lecture, and it's a usage for indeterminate structures that will also be explained. CR आवाज आ रही है? CR
यस सर आ रही है
और डिस्प्ले भी नजर आ रहा है?
यस सर
Okay, so it is well known to you that for the determinate structures, this is an example, and you might be well aware of this sort of figure. If there is a unit load, and certainly in influence line we apply the unit load, and then we remove the capacity of the support, we remove the capacity of the structure or support. What does it mean? If we remove the capacity, it means it will I will release the structure, I will release the beam so that I can play with it, so that I can play with it. So we will be giving displacement, unit displacement upward, and this will be the deflected shape of the beam if I am interested in finding out RA. Similar is the case with the RB, and this is well known to you. This is for the reaction. Now the reaction, similarly, this is the shear. Over there we will be providing at the point of interest, we will be having a cut, the open cut that will be provided, and we will be applying unit force upward, and on the other side of the section unit force downward, and this will be the deflected shape of the beam. And this vertical ordinate, this is unit in value, and this is describing the ordinate of the ILD. So ILD in general, everybody should listen it carefully, and whatsoever is spoken, that must be rewritten on your notebook, please, so that there should be proof for you, and this will certainly be helping you in when you are preparing yourself for the examination. It should be noted. So this is ILD for the shear. Similarly, for in case of having the maximum response for movement, you will be providing a couple of movement, one on the right side and the other one on the left side, and that will be clockwise, and the other one leftward will be counterclockwise, and this will be almost, this will be the deflected shape of the beam. Okay? Now this is very similar to the ILD, that is very similar to the deflected shape of the beam. So we will be these are very similar to the same approach that will also be adopted for the indeterminate beams. Same approach will be adopted for the basic theme, that will remain same for indeterminate structures as well. I explained last time, and you are well aware of this. Over there, there may be the multiple loads. Number of loads may be there, like a locomotive train that is passing over the bridge. You are well aware of this one. That may be the single load, or there may be the multiple loading. Also, there may be the distributor load, UDL or UVL, whatsoever is the case. Accordingly, you will be solving the numerical, and this is well known to you, and you have done it, you have gone through an ESA. Now, there are three methods, almost these are similar ones. The first one is labeled as influence line, influence values. What does it mean? If you just write it, even if I dictate it or not, you should write. Like if there is a simply this is a beam, okay? For the tabulation value, tabular procedure, for the tabular procedure, what will I do? Just I will draw the influence line, and this will be placed over there at 1 meter, say 1 feet 1 meter. Then I will be going, I will find out the value. Then I will place it at 2 meter, I will find a value. Then I will place 3 meter, I will find the corresponding value. I will place it at 4, then I will find, and then very close to the next support, and then corresponding value that will be found. So this is just in the form of a table. On the left side, there will be distance. On the right side, there will be the value of the ILD. So this is known. This will be known as this will be known as influence line values, influence values, and this is known as tabular procedure, tabulation procedure or tabular. Okay, tabular form. The other one is in equation form. What does it mean? You will be developing an equation for this ILD in terms of x, in terms of distance, very similar to the bending moment equation, very similar to the bending moment equation, or very similar to the shear force diagram equation for UDL, or point load. So in that case, you will be developing an equation, and just you will be putting x value and corresponding ILD that can be drawn. So this is the second approach, second procedure. The third one is Muller-Bresla principle. This is a new one, but in general you have done it, you have used it. This is not new one in a sense that you have used it already, but now in a proper form, this has been explained over here. Now this formula, this will be giving you a qualitative influence line. Qualitative, what does it mean? This is qualitative. Just you have drawn it. This is giving you an idea that when there will be unit load, reaction will be more maximum over there. It will reduce and go on decreasing till it meets the support and its value is 0. This is also qualitative. No value is given over there. So for RB, and you can see, and we can judge, you can judge that the maximum value will be over there, and it will go on reducing, and it will join 0 value at this support A. And also this is also qualitative, and this is also qualitative. So this is the Muller-Bresla principle. So equation, I have explained it earlier, that equation means you will be developing an equation, and this will be giving you, just you will be putting the value of x, and you will be finding out the value of the influence line. In this slide, this has been, there is a summary of the tabulation procedure. Tabulation procedure, you will put a unit load, you will find out, and you will repeat the step, use the equation of the equilibrium, you will repeat step 1 and 2, and then you will tabulate the values. And this is the equation procedure. Both are almost similar ones, but these have been labeled. And I have also given over there to make you clear about this one, because it will, these have been given in the literature, so you must be well aware of this one. This is not new one. Is it clear to everybody? Is it clear?
Yes, sir.
0808 1608 1608 1608. Who is this one? Repeater. 2016-08. You are being removed from the session. 1608. 1608.
Yes, sir.
भाई आप सो रहे होते हैं, ये क्या तरीका? आप जो है रिपीटर है आप?
सर इंटरनेट का प्रॉब्लम है.
मैं आपको रिमूव करने लगा था, तो आवाज इंटरनेट तो आवाज है?
सर आवाज आ रही थी, मैं माइक अनम्यूट कर रही थी, वो नहीं हो रहा था.
चलो, कोई समझ आई है जो बताया मैंने?
यस सर.
ओके. हसीब
यस सर.
बेटा समझ आई?
यस सर.
कोई कंफ्यूजन, कोई मसला बता दे, ताकि आगे चलने से पहले फिर मैं उसको एडजस्ट कर लूं. इज इट ओके?
यस सर.
ओके. सिया ठीक है? सिया
Yes, sir.
Okay. Now, now you know this is the influence line. What does it mean? Influence. It means that you have loaded the member, and what will be the response? Okay, that response will graphically be drawn to a scale or freehand, and it is known as influence line. What will be the influence of load on the beam? And what is the response? The response is the in terms of reaction. Response means reaction. So how can you judge the response of the beam or the structure in terms of reaction, support reaction, in terms of shear force, in terms of bending moment, in terms of axial force? Is it okay? CR, okay?
Yes, sir.
So now listen it carefully. Previous developments were related to fixed loading. Okay? And now, and certainly we meet with the live loads to have the maximum response, because when you will be designing a member, it then you design it for the maximum value of the response, so that it should not fail during its lifetime, so that it should not fail during lifetime. Okay? So we will place the loads one by one. Different positions will be adopted, and we will look into the maximum response. So this is the response function. So there are two approaches. There are two steps basically: position the loads and then calculate the maximum response, maximum value. What is the response? Response means support reaction, axial, shear, bending. This is response. Influence line. This is the graph of the response function. Graph of the response function for the moving load. Now for the statically determinate structure, you have done it earlier. You have seen that all the lines are straight. You can see all the lines are straight. Whether it is for the reaction, for the shear, for the moment, all the lines are which are developed. All the lines are straight. Straight line segments will be produced. Is it okay? CR?
Yes, sir.
So, but for indeterminate structures, indeterminate structures, because these are not considered to be rigid, influence lines will be showing you. Those will not be straight, but those will be in the form of curves. Straight line nahi aayegi. This will be in the form of curve. So this is the difference only. So difference is between the ILD for the ILDs. Difference between ILDs of determinate and indeterminate structures, that is this one. For determinate structures, it is straight line. For indeterminate, there is a curvature. Now, the formal definition for the principle, Muller-Bresler principle, that is the deflected shape of the released structure. Okay? Influence line is the deflected shape of released structure. I told you that you will be removing the capacity, and when you will be removing the capacity of constraint you have, when you will be removing the constraint, then it means you have released the structure to move for its movement, and then you apply a load upward, or you apply the moment or shear, whatsoever is the case, you remove the capacity by placing a cut over there. Okay? By putting a hinge over there, you remove the capacity. So this is known as released structure. Okay? So a released structure is obtained by removing the constraint. Constraint that will be removed, and it will become a released structure. This will be known as a released structure. And the formal definition is that the ordinate value of influence line for any function may be a shear, may be moment, may be the reaction on any structure is proportional to the ordinates of the deflected shape. So it means deflected shape is very similar to ILD. ILD is very similar to the deflected shape of the beam. Okay? By removing the constraint, okay, and introducing the force. By removing constraint and introducing force, which will cause displacement in positive direction or negative direction. So, or in other words, influence line of a parameter, reaction है shear जो भी है, at a point is to some scale as the deflected shape of the beam. Whatsoever will be the deflected shape of the beam, very similar to that one, there will be the ILD when the beam is acted upon by that parameter. So what will we do? We will be removing the capacity. The capacity of that parameter must be removed. Capacity will be removed, and we allow the deflection. We allow the deflection. So, in general, Muller-Breslau principle has these steps. Just release the structure, apply the deformation. So this is two-step procedure, and then third one means done. And what are the releases that you will be providing over there? Actual structure is not with the releases. This support is holding it. This support is holding the beam. So in actual structure, there is no release. What will we do? We will introduce a release. And what are the releases? When we are interested in finding out the support reaction, use a roller guide. If for shear, use sliding device. For bending moment, use an internal hinge. Use an internal hinge. So from the class, from the whole class, if anybody has any confusion, that may be pointed out, please. Everybody is welcomed. Your queries are welcomed, please. CR?
Yes, sir, clear.
Anyone else from the class? Anyone else? Please tell me. Anyone from the class? Arima? 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 Arima?
Yes, sir. Yes,
Is it
sir.
okay? Is it okay?
Yes, sir.
Okay जी. हमजा? हमजा? बेटा ठीक है? Okay. So should I consider that there is no query from your side? Is it okay? Hamza?
Sir.
Yes, yes. Yes, welcome, welcome. Who is? Anyone else? Anyone? Okay. So this is regarding the releases. Now this is the qualitative and quantitative. If only shape is there, qualitative. If values are there, quantitative, ILD. Normal, now this is the sign convention. Positive force, upward movement for the normal force. It means reaction. It means reaction. Okay? So, if it is moving upward, it is positive. If downward, negative. Similarly, for shear, clockwise rotation, positive. Counterclockwise, negative. Bending moment, sag is positive. hog is negative. Sag is positive, hog is negative. Now, underside, you can see the description. There are almost equal two types of beams, rather a single type of beam. Now this beam has been made and determined by introducing a hinge, and you know that when there is a hinge, the beam becomes determinate, but it will be depending upon the number of spans. So it is well known to you. So in this case, this is your revision, previous knowledge, and this is being compared with the latest information regarding the indeterminate structures. Now in this case, you can see when you are looking for RA, then it was given a unit displacement, and this is the deflected shape of the beam. This, you can see, this is a straight line. This is a straight line, and you have seen in your previous topics for ESA. Okay. Now this is indeterminate. You can see this is due to continuity. I have explained in the previous lectures, also in force method, what is compatibility, what is continuity, what is boundary condition. All the things have been explained in detail, and you must be well aware of this one. And what are the basic mechanics regarding the continuity? What is the basic mechanics? What does the basic mechanics says about the continuity, about the compatibility? So it must be known to you, and you should be knowing it. So in this case, you can see the beam that adopts a curvature. This is a little bit straight, but after that, it becomes a curve. It assumes a shape of a curve. Okay? Because this is moving upward, so it is positive. If it was applied, if that was given a displacement downward, it was negative. So you can see this. And what have we visualized? Just this is an imagination. This is just visualization that at this support, you will be at this point, you will be removing the support. This is support is removed, means capacity is removed, means you have released the structure. And then this has been placed over there, and this beam will be sliding in this way. This will be moving this way, upward and downward. So in imagination, you can have this to be placed over there, and this will be adopting this shape. Then further description for ILD. Once again, it is RA, and this is once again being repeated. No, for shear, for the determinate structures, what if I am interested in finding out the shear at D, ILD at point D, shear ILD at point D, then one force, unit force will be applied this way, and the other one downward, leftward. Now you can see that this ordinate, that is 1, and this is a straight line, this is a straight line, this is a straight line. But this is not case with the indeterminate structure. In this case, you can see this has adopted this beam assumes a curvature like a cup curve. Similarly, this is also in a curvy linear shape, and the description over there, shear force, it is positive, it is if it is clockwise, if rotation is clockwise, and it is negative, it will be negative, it is if it is creating counterclockwise. So it will be negative counterclockwise. You can see this curvature is like a cup almost, and this is, you can see this is moving in general, this is moving counterclockwise direction, and this is moving in clockwise direction. So this is positive, so this is negative. Similarly, and at this place you have introduced this release. This release has been introduced at point D. Then for bending moment, if I say at point E, then in case of determinate beam, to make it determinate, this hinge has been transferred to this one. I need the moment at E just to make it dissimilar from the previous beams. I need moment ILD at E. It has been made determinate by introducing a hinge at this point, and a clockwise and a counterclockwise moment couple has been applied, and this is the deflected shape, and you can see all the segments of the beam are straight enough. But this is not case in case of indeterminate. This is over there, this couple moment has been applied over at this point, and this is the assumption of the shape of the segments of the beam. This is like this one, and this is curvature. Is it okay, everybody?
Yes, sir.
No.
Yes, sir.
Shabash. Welcome. Now, can you see this one?
Yes, sir.
Yes, sir.
So in this case, this is just the repetition of your previous knowledge for the determinate beam. This is determinate, and you can see the how can you draw the ILD for the reaction, and ILD for shear, ILD for the moment. Okay. Okay. Then in case of reaction, now this is the practical utility of the Muller-Bresler principle when you are interested in finding out the support reaction. Over there you can see, just listen it carefully. Everything is written over there, and I have explained it earlier. No need to go through this one. Now you can see this is a beam, and you can see that this is indeterminate to first degree. There is a roller, there is hinge, there is roller. So here two forces. Inner hinge, this acts like a roller. It should be noted. It acts like a roller. This is very similar. Or you can also place a roller over there. So in this case, you can see that this is indeterminate beam. So in this case, what I do, this is actual structure, and you will be following the force method. What is the procedure in the force method? In force method, you apply, you divide, develop the from the original structure, you get a primary structure, and then another auxiliary structure. In the primary structure, just you remove the redundant, and in the auxiliary structure, you apply the redundant. Is it okay? Am I right?
Yes, sir.
Anis, is it okay? Anis? ठीक है बेटा?
Yes, sir.
समझ आ रही है?
Yes, sir.
शाबाश। So
सर प्राइमरी स्ट्रक्चर में
हाँ जी, हाँ
प्राइमरी
जी।
स्ट्रक्चर में ए पे फिक्स पोर्ट है।
प्राइमरी स्ट्रक्चर में नहीं, ए पे फिक्स, अभी तो मैं उधर आ रहा हूँ ना, आ रहा हूँ। अच्छा, now this is actual structure which is acted upon by some force. This may be unit force. Now this is the primary structure. This is actual and this is primary structure. Now in this case, you have released it. You have released it. You can see this, you have released it. It means this is removed. One action is removed, one response is removed in vertical direction. What does it mean? And at this support, at this location, you have introduced a roller guide. Roller guide. What does it mean? It can allow the movement of the beam in this direction, but not in this direction. This is roller guide. यहाँ पे roller लगा दिया vertical. अनी समझ आ रही है अनीस? आपने किसने बोला था?
यस सर आ रही है। ठीक है सर।
नहीं नहीं, जो बोला कौन था? आप बोला थे बिलाल?
सर बिलाल। जी
ठीक है,
सर।
समझ आ गई बात की? This is not fixed support.
यस यस सर। ओके सर।
हाँ जी, this is not a fixed support. अगर मैंने इसको सपोर्ट फिक्स सपोर्ट करना तो फिर ये क्यों किया ऐसा? हम तो रिएक्शन को कम कर रहे हैं, बजाय इसके हम बढ़ा दें उसको। ये तो गलत हो गया। ऐसे ही है
वो
ना?
सर क्लियर नजर नहीं आ रहा था इसलिए पूछा मैंने।
अच्छा, नहीं अब नजर आ रहा है ना?
जी सर अब ठीक है।
हाँ, this is roller. So this is roller guide. You will be introducing a roller guide. So you can see you have removed one redundant. VA, vertical force, VA. Plus auxiliary structure, you have applied VA. Okay? Now, under its effect, under applied loading, this will be moving upward. And under this VA, it will be moving, should have been moving downward. The sum of these displacement must be 0. ऐसे ही है? फोर्स मेथड में यही है ना?
यस सर।
फोर्स मेथड में यही है ना कि एक्चुअल स्ट्रक्चर लोडिंग की वजह से जो डिस्प्लेसमेंट है और रिडंडेंट की वजह से जो डिस्प्लेसमेंट है, दोनों का सम 0 हो। हाँ भाई हरिमा, इज इट ओके?
Yes, sir.
एहतशाम, you are being removed. एहतशाम, on hold. I think he is trying to respond, but unfortunately, no. Hamama,
Yes, sir.
समझ आ रही है बात की?
Yes, sir.
कोई दिक्कत, कोई कंफ्यूजन?
No, sir.
Okay. So, according to force method, the displacement or deflection, deformation in primary structure plus auxiliary structure should be 0. This is our basic information. What does it mean? If it is delta AD, then plus it will be VA into delta AA. Due to VA, this deformation will be VA into delta AA. This is well known to you. At the start, I developed this expression. Total summation must be 0. And from this, we can have unknown value VA, and it will be equal to minus delta AD over delta AA. Delta AD over delta AA. Now, using the principle of this is according to force method, this is the force method also in accordance with the principle of law of superposition, principle of superposition, the summation must be equal to 0. If I apply Maxwell theorem, then the displacement by this force at this one and displacement at this D due to VA, both are same. Due to, sorry, unit load. If I apply over there unit load और actual load जो भी यहाँ पे act कर रहा है, इसकी वजह से यहाँ पर और इसकी वजह से यहाँ पर जो डिस्प्लेसमेंट है वो दोनों सेम है. समझ आ रही है या नहीं आ रही? So this is Maxwell theorem of reciprocal displacement. If unit load is applied over there and there will be displacement, and same load has been applied over there, then the displacement over there both will be same. Both will be same. क्यों भाई, ठीक है गलत है CR?
Yes, sir. ठीक है.
Maxwell theorem, हाँ जी. So I can replace delta AD with dA because this is due to unit force. This is also due to unit force. This is also due to unit force. This is also due to unit force. So because this is downward, so I can write it minus. So both will become positive. So I can replace delta AD with delta dA, and I get this expression. Delta dA will be taken out and there will be 1 over delta AA. Now, this can be defined that unknown value is equal to the deflection under unit load, and it is multiplied by a reduction factor, or delta displacement at this point due to unit force, that will be equal to 1 over VA into delta dA. Delta dA that will be equal to delta dA. Okay, so from Muller-Breslau principle, removal of support and application of vertical unit load gives a deflection curve to same scale as that of ILD, and VA is equal to delta dA. VA is equal to delta dA, okay, with reduced factor 1 over delta AA. 1 over delta AA is known as reduced factor, and this is the reduced factor. It is also known as reduction factor, reduced factor. Okay. Now this is regarding the reaction. The next one is for the shear. You can see this one. The same thing. What will you do? This is a beam. I need shear at E point. I will, providing over there, I will introduce, hypothetically, I will assume, imagination is there, I visualize sliding device. I will introduce a sliding device at this point. Unit force, shear force. This is sliding device, and the displacement that is over there, it is delta EE. Okay. Now, under the effect of actual loading, there will be the displacement, and under the effect of the shear force, this will be delta EE. And if I, on the same lines as I have done earlier, if I define the value of VE, it will be equal to delta DE, means displacement at point D due to shear at E, displacement at D due to shear at E, multiplied by a scaled factor, reduced factor, reduction factor, scale factor of 1 over delta EE. Similar expression has been given by the support reaction. I told you this one. नजर आ रहा है भाई? CR.
Yes, sir. Yes, sir.
You can see displacement at D due to force at A. Displacement at D due to force at A multiplied by a reduction factor, reduce factor, scale factor, AA.
एक्सक्यूज मी सर, शायद आपका माइक ऑफ हो गया है।
अब आ रही है आवाज?
यस सर।
एक मिनट ऐसे मिला अभी होगी इंशाल्लाह। ओके जी, अच्छा वो मुकम्मल हो, समझ आ गई इसकी शेयर की समझ आ गई?
यस सर।
ओके जी, नाउ VE shear force at point E is equal to delta DE, means deflection at any other point where the actual loading is applied, that is in the primary structure. ठीक है, ये D point वो है. So at that point deflection at D due to force at E, shear at E जो आपने किया है, और it will be multiplied by a scale factor 1 over delta EE. ठीक, then the movement, for the moment same thing, I need moment ILD at point E. I will be introducing a hinge. When hinge is provided, I will be giving the rotational displacement using a couple of the moments this way, and you have done it earlier in your ESA subject. And on the same lines, you will be finding out the moment at E point. It will be delta deflection at D due to moment at E multiplied by a scale factor, and this is the rotation moment at point, rotation at E due to moment at E. So this is all about the ILD for indeterminate structures. Now for qualitative ILD, introduce a roller guide for reaction, sliding device for shear, pin for movement. And if you are to find out the quantitative, have the expressions like this one. Just put the values, divide each value by the displacement found at the point where unit load is applied. You are going to divide it, this displacement by this displacement. ठीक है, the value of the ordinate will be found. So this is regarding the basic procedure to draw the ILD using Muller-Bresla principle and applying the force method along with reciprocal displacement method and the law of superposition. All these 4-5 approaches, those have been summed up in this single topic. So if you are having any difficulty, face difficulty, you can tell me.
सर वो एक स्टूडेंट का मैसेज आ रहा है कि एडमिट कर दें।
कर दिया, ठीक हो गया। सो ये आप ये देखें और now once again I move back to the original slides. Now these will be shared with you inshallah as early as possible and CR अगर ये मैं तुम्हें भेजूं तो ये आपने बाकियों से भी पूछ लेना कि भाई उनके पास है या नहीं है, तो आपको शेयर कर देना, ठीक है?
ओके सर, मैं शेयर कर दूंगा।
अच्छा, now same thing has been explained over there. You can see that was the simplest form. In the previous slides I have explained it, and the same thing is given in the book. You can see, okay, you have applied this unit force has been applied. Due to this one, FAD will be deflection, and you are applying the redundant force. Then this will be the displacement. Both displacement summation must be 0. You can see this one. So from this redundant force has been obtained. So this redundant force will be negative. Now, as you know, FAD and FDA both are same. Under unit load, under unit load, under unit load, under unit load. ये वाली और ये वाली रेसिप्रोकल डिस्प्लेसमेंट का यही है। तो चूंकि ये सेम है, इसलिए if I replace AD with minus DA, because this is downward negative deflection, so I will be having AY equal to this one, and this is known as scale factor. Scale factor. Similarly, this is for shear force. You can see the original shape. This is also the scale factor, and this is the deflection. You can see this one. Similarly, for the moment, this is this is the scale factor, and all these things are over there. So I just make it a little bit bigger. Just try to go through these one, please. ठीक है, ये मैंने आपको ये इधर भी दिया हुआ, यहाँ से अगर आपको समझ आती है ये और ये, ठीक है, इसको देखिए जरा। CR
ओके सर।
ये बेटा इसको रिव्यू करें। मैं अभी आपको फिर जो है ना, मैं देखता हूँ कि भाई आपको कोई ऐसी ऑब्जर्वेशन है तो मैं फिर एड्रेस करता हूँ। 5 मिनट में सिर्फ आप देखिए, 5 मिनट।
ओके सर। यस सर।
हाँ जी, ये आप इसमें से ये देखे हैं आपने? ठीक है। सो यू विल बी शेयर विद दीज स्लाइड्स। और ये क्वालिटेटिव ILD है, ये भी आप देखें। फॉर हैविंग द रिएक्शन एट A, this will be the deflected shape, and you can see this is deflected shape and this is ILD, qualitative ILD for RA. If you are interested in finding out the ILD for RC, then you will be applying a force. This will be the deflected shape. And in all the cases, you can see that there is a curvature. And this is the difference. Curvature will be there for indeterminate, and straight segments will be there for determinate structures. And this is for shear force. This is negative bending moment. This is positive. And you can see the shape of the beams, and also this one. So all the things have been explained, and similarly, this is also the similar one with some other description or notations. F has been used. F means deflection. The same thing has been given over there. This is for reaction R1. This is for R2. R2 is the middle support. You can see you have given the displacement. This will be the reflected shape, and this is for under the unit load. This is for shear. You can see this one, this deflected shape. This is VE, as we have already calculated. This is for the moment. Now, the basic advantage for this influence line this can also be applied for the frames as well. In this case, you can see for the shear, you will be introducing a roller, you will be introducing a sliding device, and then you can visualize the deflected shape of the columns as well as beams. So as you know that this is deflected upward. Okay, so to counteract, so you will be placing the load at this location, you will be placing load at this location, okay, and you will be loading this part for positive maximum shear, positive upward, positive maximum shear के लिए आपने इसको load करना है. When you will be loading this this way, then you will get maximum shear, positive shear. Similarly, for negative shear, wherever there is negative description, this one is negative, so you will be loading accordingly. UDL will be loaded over there, and you will be having maximum negative shear. Similarly, for the moment, positive moment, positive के लिए you will be loading this one. And you can see for negative this one, and this one. This is for maximum negative moment. Now, for the solution of this one, have you gone through the conjugate beam method, CR?
सर वसीम ने थोड़ा सा इंट्रोडक्शन दिया लास्ट लेक्चर में. वैसे प्रीवियस जो कोर्सेज है उनमें हमने नहीं वो पढ़ा हुआ.
नहीं, अच्छा, वो स्ट्रेंथ ऑफ मटेरियल में था. अच्छा, ये अभी था.
सर वो कॉन्जुगेट बीम वाला पढ़ाया कोई नहीं हमें. आई थिंक स्ट्रेंथ ऑफ मटेरियल में भी नहीं पढ़ाया और एलिमेंट्री स्ट्रक्चरल एनालिसिस में भी नहीं करवाया.
नहीं, कॉन्जुगेट बीम मेथड आपके स्ट्रेंथ ऑफ मटेरियल में है. तो डॉक्टर सफीर ने नहीं पढ़ाया?
सर मेरे हिसाब से तो नहीं पढ़ाया. बाकी किसी और स्टूडेंट से पूछ लें, शायद मुझे याद ना रहा हो.
एनीवन एल्स फ्रॉम द क्लास?
मेथड नहीं किया था हमने.
नहीं किया सर, वो नहीं करवाया. नो सर.
सीआर में तुम्हें वो बना ये कर देता हूँ. नाम क्या तुम्हारा? आप क्या नाम है?
सर उजैर.
ओके, ये मैं आपको ना प्रेजेंटर बना रहा हूँ, तो ये आप डाउनलोड कर लीजिए. प्रेजेंटर हो गया?
सर प्रेजेंटर तो हो गया, लेकिन सर डाउनलोड का ऑप्शन मेरे पास नहीं आता. वो पहले भी आपने काफी दफा प्रेजेंटर बनाया, लेकिन डाउनलोड आई थिंक सिर्फ आप वाली साइड से ही हो सकती है.
अच्छा, चलो ये आप ऐसे करें कि इसको फिर इसको कर ले. ठीक है, इसको स्क्रीनशॉट ले लें और फिर.
यस सर, वो सर स्क्रीनशॉट तो मैंने ले लिए.
हाँ, ठीक हो गया. तो चलो, ये कॉन्जुगेट बीम मेथड तो बहुत जरूरी था. तो ये आपको किसने पढ़ाया था स्ट्रेंथ ऑफ मटेरियल?
सर डॉक्टर सफीर, उन्होंने ही करवाया था.
चलो आप यहाँ तक जो है इसको आप हैंडल करें, और फिर इंशाल्लाह मुलाकात होगी. और स्टे ब्लेस्ड इंशाल्लाह. ठीक हो गया उजैर? Any query from the class? Anyone who wants to have a question? Zunaira? माइक खराब है. पिछली दफा भी माइक खराब था तुम्हारा. ओके जी. So okay, so we will meet inshallah next time. Stay blessed. Allah Hafiz. Assalamu alaikum.